if based on the James Webb, that everything that we know is turning out to be false.
The Big Bang Theory says the universe started from nothing, marking its very beginning. Before this event, there was no time or space. But what if time isn't real and the Big Bang Theory is wrong? New discoveries from the James Webb Space Telescope are challenging the Big Bang Theory. It turns out the Big Bang might not have been the start of the universe, and time itself could be just an illusion. This surprising idea is supported by the renowned British physicist Roger Penrose. You might wonder how the James Webb Space Telescope backs up the idea that time is an illusion, and if the Big Bang Theory is incorrect, what other ideas explain the universe's origin and evolution? Let's find out. Our universe's journey, starting over 13.8 billion years ago with the Big Bang, has hit a bump, especially with new images from the James Webb Space Telescope. While these pictures are stunning to us regular folks, they've rattled cosmologists and astronomers. But here the big surprise is, these images clash with the long-held Big Bang Theory. This theory has been like gospel to many scientists, so this new data has really shaken things up in the science world. People like Alison Kirkpatrick from the University of Kansas are scratching their heads over this, wondering if their past work needs a rethink. In the new snapshots from JWST, galaxies look odd. They seem too small, smooth, and ancient. This goes against what we thought about galaxies getting bigger as the universe expands. Even the ones with lots of stars appear tiny compared to what Hubble showed us. Not just size, but the redshifts in these galaxies are higher too. It's like they'd have to be tiny for what we see to make sense, which is pretty wild. Fans of the Big Bang Theory expected to find densely packed galaxies, like Mighty Mouse galaxies. But JWST's pics show galaxies similar to today's, not beaten up from collisions as predicted. Without big collisions, small galaxies can't become big ones like we thought. This challenges the idea of an expanding universe. Maybe there wasn't a Big Bang after all. Also, the ages and numbers of galaxies in the pics don't match the theory. JWST is discovering way more galaxies than we thought possible, suggesting an explosion earlier than we guessed, casting doubt on the Big Bang Theory. Time is a hot topic among scientists. Some say it's a human invention, proposing that everything happens at once. This challenges the idea of time always moving forward. Others suggest time might reverse when the universe stops expanding. Picture everything rewinding like a movie playing backward. What comes after this big crunch is a mystery. Some think the universe will restart, while others say it might vanish. Some even think this cycle repeats, creating many universes. Scientists are rethinking time, proposing a block universe where past, present, and future coexist. Reality might be like a painting where everything is already there, but we perceive time ticking along. Scientists like Max Tegmark and Julian Barber offer different perspectives on time. This leads to questions about Einstein's theories. What if he was wrong? Would discarding his ideas help us understand the universe better? In science history, doubts often spark big changes. Copernicus challenged the idea of Earth as the center, and Einstein revolutionized our understanding of gravity. Will questioning Einstein lead to another breakthrough? Einstein's spacetime theory has ruled for ages, especially after we spotted gravitational waves in 2015. But now, there's a new challenger in the physics arena. Enter quantum theory. Imagine a world where tiny particles can be in many places at once. Picture Schrödinger's cat, alive and dead at the same time in a box. It's weird, right? But this quantum world doesn't mesh well with spacetime's smooth flow. Even top scientists like Sabine Hossenfelder see the clash. Einstein says gravity can't be in two spots at once, but quantum physics begs to differ. Where does gravity fit in this quantum puzzle? No one knows. And when scientists try to blend these theories, the math goes wonky. We're talking about numbers bigger than infinity. Now, physicists want peace. They're hunting for a theory that marries quantum magic with gravity's pull. Q-string theory. It suggests our universe is like a symphony of vibrating strings, no experiments needed. But some prefer loop quantum gravity, LQG. It says space isn't smooth, but a web of loops, like stitches in cloth or pixels on a screen. It sounds good, right? But there's a catch. These space stitches are super tiny, like microscopic small. We're talking about stuff a trillionth of a trillionth of a trillionth of a meter. And testing this theory, it's no easy task. We'd need a particle accelerator the size of the Milky Way. But some clever minds have a plan involving super-chilled cesium atoms to see if gravity acts quantum. In the wide, open space of the universe, there are tiny imperfections waiting to be discovered. When light travels from far-off places, it journeys through lots of space. Even though these flaws are minuscule, if they pile up, they can make a big impact over long distances. For years, scientists have been studying bursts of energy called gamma-ray bursts from distant locations to understand the universe better. These bursts occur when massive stars meet their end. However, when we examine the light from these bursts closely, we find perplexing phenomena that defy explanation. It's unclear whether these peculiarities occur during the journey here or are inherent to the bursts themselves. It's a puzzling mystery. To delve deeper into this mystery, we may need to rethink our perception of space. While Einstein likened space to a stage where events unfold, some scientists, like Friedel, Lee, and Harmonic, propose a different analogy. Space is more like a dance between entities. They argue that space is shaped by interactions, especially on a microscopic scale. It's a novel perspective that could offer fresh insights. The modulus spacetime theory is intriguing because it could resolve a major puzzle in physics. When we observe tiny particles, they seem to communicate instantly, regardless of the distance separating them. This baffled Einstein. However, this new theory suggests that distance isn't merely about physical separation, but also about interconnectedness on a microscopic scale. It's akin to feeling close to someone even when they're far away. Friedel, Lee, and Minnick have been pondering this concept for some time. They're proceeding cautiously but are enthusiastic about their progress. Their approach involves examining the tiny world influenced by gravity rather than attempting to grasp gravity itself, as other theories do. It's a different strategy, but they're hopeful it could yield significant discoveries. Understanding space and time may seem like a pursuit reserved for intellectuals, but it's relevant to everyone. Our entire world hinges on comprehending how things operate on a microscopic level. Although the effects may not be immediately apparent, they could shape our future existence. It's akin to anticipating significant changes when a new ruler ascends the throne after a lengthy reign. Scientists are diligently working to unravel the mysteries of the universe and determine what lies ahead. Now tell me, what are your thoughts on this matter? Let us know in the comments section.